Hello, I'm Dr. William Schlosser, Washington State University, School of the Environment. This is my classroom. In this video, we will discuss how to use data arrays captured from PRISM, specifically data representing Kamiak Butte. You can do this, of course, for any region you assess. In this example, I guide you through the use of Microsoft Excel, running on a Windows 11 operating system. We will do the same for Excel on a Macintosh in a different video. We will cover some necessary data management steps, including the opening of the CSV file, converting it to an MS Excel file. Then we will look specifically at certain data management tools to parse out our data with segregations for monthly averages across this 125-plus year period. Finally, we will make charts with two vertical axes to best show your data. Climate reports statistics, usually mean or variability of weather. We like longish dataset reports, some reaching over 100 years. But when we have those data, we can bifurcate our data into segments to show climatological changes between periods. This is how climate change is sometimes stated. We use databases of daily or monthly information to create monthly and annual averages through time. This is how PRISM data has been assembled, with new data added continuously through time. We can report these findings as figures, charts, tables, or geospatial analysis maps. Each presentation gives the analyst unique means to share the vision. Weather-based database values are associated with specific locations on Earth. These are drilled into the level of 4-kilometer and 800-meter cells. If you're a GIS wonk, you would be saying right about now that we think of 30-meter cells as sloppy because we get 1-meter LiDAR data these days. Well, that is meaningful when examining elevation data, but this is about climate, and we may have weather collection stations separated by dozens or hundreds of miles, so 4 kilometers is outstanding, and 800 meters is amazing. Well, we head into web domain managed by Oregon State University, the PRISM Climate Group. I want you to be very specific about the citations of your data. PRISM is a data source, but you need to see how to cite it right. Look to the home page, FAQ section, to see if citations are a frequently asked question. You see it at the bottom of the page, but it is also at the top of the page menu bar, far right side. Click it. Third row down. How should I cite the data? Yep, click again to see another hyperlink for the PRISM terms of use. You see it right away. There are a few types of data they provide, be it geospatial data or tabular data, presented monthly and even daily. These are the references to the data. PRISM Climate Group. Look specifically at the end of this citation showing accessed 16 December 2020. Make sure you use the date you actually accessed these data, not that 16th of December. Use the date you have. Make it a citation of your data. This 16 December 2020 is just an example. You will enter these specifics into the Citation Manager in MS Word for APA formatted citations. Populate your records and know this will change for each array you collect from PRISM. Take yourself back to the home page. There are several weather data options you can seek. One is the GIS formatted data with specific pixel data bound with longitude and latitude for each cell, which also carries dates and each weather attribute you care to document. Those are great data with extremely large spatial data collections. You have seen examples of those on the geospatial maps of temperature by month summarized for specific regions. They were on the lecture video for this climate section. For this trek, we look specifically at tabular summaries for a specific region, specifically Kamiak Butte. For this, go to the menu bar and select Explorer. The PRISM data arrays have been updated periodically through the years, not only for the weather data analysis, but also for web domain presentations. These leading web page sections inform about the data, its collection standards, timing, and about the geospatial data. You can select the Hide Text if you are all set with these details. Click this to clean the screen. You can turn it back on again quickly. This guides you into the interface page, which recently has benefited from some strong modifications. You see the multi-state image on the right side of the screen, but getting specifically into the point you want, it can take some time. Better, you can select a state and county from the region you want to explore. Washington and Whitman County. Great. That brings us in close, but we can drill in closer than this. Here's a good one for you to select the coordinates radio button. Enter the longitude and latitude coordinates I show on this video, right now. Enter them appropriately and you will see exactly where you want to be. Enter the coordinates and click Zoom to get right onto it. On the area map, you see the red circle for these coordinates. Enter the plus or minus boxes in the upper left corner of the map view window. You will zoom into the red circle. I use the rollerball on my mouse to zoom into the point. Hover your mouse over the point and roll the ball. You see a grid of the pixel sizes you are working with. Some are 4 kilometers, others are 800 meters. This shows 800 meters. As you zoom in, you see area location names like Pullman to the south and State Highway 27 trekking north and south. Get in and you will see topographic relief on the map. That is Kamiak Butte. Look to the upper right side and see the blue box. Click on it. This is a big change they recently added to this PRISM web interface. Here you can select the overall grids for 4 kilometer or 800 meter meshes. Below this, you see base layers showing what is seen on the general entry point for terrain, but above this is Esri Satellite or Bing Hybrid. Try these out. My first selection is for the Esri Satellite image. This aerial imagery is consistent with what we see for NAPE aerial imagery and GIS. Zoom in on the coordinates I shared with you as shown on the red circle. As you get in closer, look for those signals we know, like the path from the county road to the turn to Kamiak Butte. You see the woodlands, the roads, and even the parking area as you enter the site. You can click and drag on the image to move it around. This confirms that you are looking at the area where WSU Virtual Ecology web domain is housed. This is where all the camera trap images are collected. Alright, we confirm this is the 800 meter pixel we want to investigate. It looks rectangular. That is a feature of the geographical projection of our round globe as presented on a flat screen image. All is good. We next explore what data we want to collect for this location. For this, look to the left side of the screen. In the Data Settings panel, look for selected radio buttons. Select Precipitation, Minimum Temperature, Mean Temperature, Maximum Temperature radio buttons. There are several additional options you can investigate, such as the VPD or Vapor Pressure Deficit, Dew Point Temperature, Cloud Transmission, and even measures of solar radiation. Most of these are new as of 2022 and give some outstanding opportunities to use. For now, we will focus specifically on temperature and precipitation records. Step to the next panel down where 30-year normals are displayed. When you select a different radio button, this one will unselect. The bottom two options are where our interest is focused today. We can begin with the Monthly Values radio button. This uses daily weather data to summarize into monthly averages. You will select the beginning month of the year and then the ending month of the year. Everything will be summarized into monthly averages for each array selected. We step into the absolute beginning of this data set, January 1895. I move to the ending date as I am doing this demonstration in June 2022. When I select the ending month, I see only January through May are available. Well, obviously, data for June are not yet collected, as those days have not even happened yet. But when I do select the month of May, I see a provisional data warning is made. Those data may change for 6 months after being first submitted. Data are sometimes supplied late, sometimes there is an error. Hey, data administrators at Oregon State University will check and triple-check these values to make the best analyses they can. It can take a little time. I see that even for January 2022, those data are still provisional. I need to decide which is more important, breadth of data or accuracy. I want to make summaries using data which span years, like January through December. Okay, I change the year to 2021 and select the ending month of December. Immediately, I see the provisional data warning is cleared. Unlikely to change. Good. Now I want to select the units of measure I want. I am selecting English units. I also keep the selection for Interpolate Grid Cell Values. It enables the geospatial kriging and variography with topographic averaging between physically located weather stations. This is enabled for the data we want. It is the crystal ball of time travel looking back in time. Now the data are almost set, but it is not yet ready for prime time. Take the mouse to the controls area of the display. You see the Retrieve Time Series button is colored in brown, while the others are not yet available. This means that although we have selected the data we want, it is not yet brought into your browser's data access. Click that brown button. It paused for a second and then highlights the Download Time Series button. That is good. But first, let me look at this series summary by scrolling down the page just a little more. This shows a series of bar charts with periodic summaries. These are not months. They are showing one column for each year in the array. These are all right, and they show annual changes for these values, but we know that annual precipitation is not meaningful when considering precipitation falling at temperatures when plants can pull it in. The next section shows the 3 temperature measures we requested, and we are relatively consistent temperatures range for the 125 plus years. This is not the chart array I want to use for any of the analyses we will conduct today. This verifies the data as requested, and they are what we want in tabular arrays. This is looking right. Now I am ready to pull the data to my local device. Click on the Download Time Series. It takes a second to prompt you to give a location where these data can be saved. It will only send the data to you as a CSV file. Comma-separated values, or CSV files, are a plain text file that contains a list of data. CSV is a plain text format with series of values separated by commas, whereas Excel is a binary file that holds information about all the worksheets in a workbook. CSV are small files that are delivered across all platforms. Excel will convert them immediately when requested. I select a save location on my local device. If you do not have room on your main computer drive, I recommend you use a memory stick. I do not recommend putting your calculation data on the cloud while you are working with it. Remember where you stored it and change the name to make it something you will recall. Leave the file type as .csv. When ready, click Save. Monthly summaries are now on my device. Now we seek the daily values for the same Kamiak Butte territory, loaded with the same precipitation and temperature measures. When the Daily Values radio button is selected, you see the now familiar starting and ending date radio buttons. You go through the same beginning date scroll to see the date reach back to January 1981, not sooner. The ending date selection is interesting to see that 31 December 2021 is still treated as provisional data. After nearly 6 months since the ending of the date when it was captured, that information is still provisional. I can get a solid feeling for the flow of data by clicking on the Retrieve Time Series. Scroll down a little and see the summaries show no obvious changes at the end. So maybe they will be acceptable for the summaries I want to make. You must select the Load Data Series brown button again to capture the daily values you want. Click on the Download Time Series Data Array. Again, I make a name change to set it specifically as the daily data I want to work with. Keep it as a CSV file, just as PRISM prepared it. You now have 2 data arrays for your analytical use. We next analyze the climatological data we captured from PRISM about Kamiak Butte. We need to convert the CSV file of 1895 through 2021 we downloaded from PRISM to open it in MS Excel. Open Excel and use the File Open command to navigate to the location on your device where this is located. You can get to the opening location, the file may not appear. Take your mouse to the lower right corner and toggle the pull-down screen. You see many file types to display. Well, select the top option, ***, for the file types. There it is. Select the correct file to open it. Conversion into Excel is super fast. Since we are on the topic of file types, this is a great time to save as. File ribbon and use Save As to Excel's XLSX file type. Hey, earlier I recommended you put these work files on your local device, or at least on a memory stick, not on the cloud. Cloud-based documents often cause delays, costing you time and energy. A simple memory stick will last for years. Be good to yourself and do it. You can work with the CSV file format, but only for this session. Then, when you open it again, all your formulas and charts will vanish. You need it to be held as an Excel file. Your file is saved and we are game ready. It is time to clean the screen presentation a bit. There are a couple of ways to adjust the screen size in Excel. Either use the screen size controls in the lower right corner of the screen, or do like I do and just hold down the Control key, the CTRL, on the keyboard and roll the mouse ball. Adjustments are made. Next, click on the upper left corner of the calculation sheet to click on the tri-chevron and select all cells. Navigate your mouse to the joint between columns A and B. The cursor changes to a double arrow shaft. Double-click on the gap. Immediately, all cell widths are adjusted to the longest width of each column. Here, we see the adjustments to be too wide for the top 10 rows. It is okay. All you need to do now is unselect the entire sheet. Click on any cell. Then get the shaft back between column A and B by clicking and dragging it left to reduce the width of column A. There was nothing in the top 10 rows except the information in column A. These are metadata entries for this sheet. You will be able to use this for what you report in your documents. This is in good shape, and you can see the data you will use. Some screen navigation adjustments are needed. To navigate quickly, I place the cell selector on any cell. Use the keyboard arrows to move to the A column, any row. Hold down the Control key, CTRL, and tap the down arrow key on the keyboard. Immediately, you are teleported to the bottom entry of this column. You landed on data for December 2021. Very fast. Return to the top by holding the Control key on the keyboard and tapping the up arrow once. Again, very fast, and you are at cell A1. Direct your cell selection to A12. This is the top of the data rows you will use. It shows January 1895 in column A, and the other data arrays are in the following 4 columns. I use the freeze panes to allow me to scroll through the data while leaving the headers for them in place. This happens by going to the ribbons at the top of the program interface. Find and click on the View ribbon. There are 3 options for this menu item, and freeze panes is the one I want. Right away, you can scroll through the data to leave the column headers stationary. Nice. Start the analysis portion of this trek. Select column A by clicking on the top of this column. The entire column is selected. Use the mouse to right-click on this column to see a double icon selector appear. Look down in the column to see Insert. Click it and see a new column A appear. Perfect. Now take the cell selection to A11 and give it a title of MO. Move the cursor to A12 and begin the entry of a formula by typing the symbol equals. The formula is equals, right, open parentheses, B12, comma, 2, the number 2, close parentheses, no spaces. This tells the program to look at cell B12 and report the last two characters on the right side. This is how we know which month the data represents. I want you to consider what these characters mean. They look like numbers, but observe the data in these cells. In columns C through F, all the numbers are right justified. Column B is left justified. That means that all the data in column B is treated as text, just as if it were populated by letters. This is why the report comes out as 01, not just the number 1. We know what it means and can use it to serve our purposes. Take your cursor to the lower right corner of this cell and see the little plus symbol appear. Double-click this corner and the calculation is repeated for the entire column. You can even control down arrow to jet to the bottom of this row and visually confirm it copied all 1,535 rows. Of course, when you do this, the number of rows will be different. More data coming soon. Well, jet back to the top of this column with a control up arrow. I want to select a representation of these data to port it to the new sheet. Put your cursor at A11. Hold down the Shift key on the keyboard and tap the down arrow key several times until you have selected through the cell with 12 entered. That takes us to cell A23. I use the keyboard to copy this by holding down the Control key and tapping the letter C. This is the familiar Microsoft copy command. You can see the ants marching around these cells to confirm what you copied. It is being held in the RAM memory, ready to paste. This is where you create a new sheet. Notice I said sheet, not workbook. The workbook you have can hold about 260 sheets on a 64-bit machine. Click that little plus symbol at the bottom of the sheet areas. A new sheet is created. Great. Now put your cursor in the new cell A1. Adjust the zoom of this scene to make it a little bigger. Now, with your mouse, right-click on cell A1. Remember, the data we have on the clipboard is text, not numbers, even if they look like they are. In this applet, you see the paste options appear with 6 sub-options displayed below it. Look at the second option to see a clipboard with 1, 2, 3 displayed. Click on this and the exact format of the data you selected appears. If you just tried to Control V for paste, the data would be empty because it would be pasting the formulas to these cells. Not what you wanted. This is our new workspace sheet, and it needs some calculations to appear here. In column B, I want some labels I can use on these graphs that I will make. Enter in cell B1 the label months, M-O-N-T-H-S. In cell B2, enter the 3 characters for J-A-N. Strike enter. Put FEB in B3 and MAR in B4. You can stop there and select these 3 labels with the mouse or by using the keyboard to hold down the Shift key and use the arrows to select all 3. Then move to the lower right corner of this selection. See that now familiar little plus sign and double-click it. The abbreviations for all 12 are produced. That was easy. For the next 4 columns, I want to copy labels from the main data array. Go back to the sheet selections in the lower panel area and select the main data array sheet. I use the mouse to select the cells C11 through F11. Control-C copies the data to my clipboard. See those ants marching again. Skip to the new sheet you made and place the cursor at C1 and type Control-V for paste. There they are. Do that Select Entire Sheet command again, upper left corner of the sheet, and double-click. Put your cursor between any 2 cells and double-click the sheet to set new widths for this sheet. Fast and easy. Clean workspace. This is where we'll make the program work for you. In C2, you will type a new formula to calculate the average monthly precipitation from the data for Kamiak Butte. Enter equals average if, no spaces, open parentheses, and see it expects range, criteria, and average range. This needs attention. We know the criteria of 01, 02, 03 to represent our months, and here's where we will use it. All the data are segregated by months, so we inform where those links are made in relation to the data we will use. We take note of our first cell we use, which on this array is cell A2. showing 01 for January. No use is made yet, but keep that cell address in your mind. We need to start by telling where the source data are located. So with the command entered as equals average if, open parentheses, right there, you click on the main data array sheet. Direct the mouse selection cursor to cell A12 on this sheet. You will select the entire column of data, that is A12 through A1535. I did that by holding down the Shift key and tapping the down arrow on the keyboard. This now needs a comma to step us into the next part of our virtual reference. The formula gives reference to the sheet and the cells you want to use. Now it wants you to enter the criteria for making the match. Oh yeah, that is the cell A2 I referenced a minute ago. Type A2 here and follow it with a new comma. Now the program wants the average range. We are starting with the PPT column to summarize monthly precipitation. You see it here on the array we are standing at. We are already at the bottom of this column, so put the cursor on cell C1535. On the keyboard, hold down the Shift key and tap the up arrow once. Just like that, you have selected the entire column of numbers. Make sure the selection is pulled back from the label for this column. Start just with numbers. All the data are identified, so you can end this column with a closed parenthesis. Strike Enter, and you are ported back to your calculation sheet to see it represents 2.72. Wow, your cell may look different. If for nothing else, it will most likely be more data when you attempt this for your analysis. It is telling me there was an average of 2.72 inches of precipitation in January, falling at Kamiak Butte during this 126-year period, 1895 through 2021. That cell can be tailored a little, starting with the significant digits. You can do this one fast by leaving the cell selector on C2 and mouse tapping the home ribbon. Find the number panel and select the comma icon. It shortens it to display two significant digits. Now I want to replicate this calculation to all other cells in this column, knowing that the A column changes for each month. This is why we made it like this. When I look at the calculation cell, I need to force it to use the relationships in relation to what stays the same and what changes for each row. You see the formula created to make the references in the main array. These need to be locked to the row and columns referenced. We do this by placing the cursor in the C2 formula line, where it reads A12: A1535. You will place a $ symbol to make it read $A, $12, $A, $1535. This tells the program to lock the calculations to these cells no matter how references change. This is locked. Scroll to the right and past the point where you see A2. That one needs to float. Leave it alone. Keep moving to the right and find C12: C1535. This gets the change as well to become $C, $12, $C, $1535. With this, you strike Enter. Same response as before, but now you can double-click on our friendly plus in the lower right corner of the cell. It replicated in this column, and you see the monthly summaries are all made perfectly based on these data. Skip a cell and enter equals sum, open parentheses, C2, C13, close parentheses, and strike Enter. Just like that. You see there is an annual average of 21.47 inches of precipitation at Kamiak Butte based on these 126 years of data. That was one column of data. Now we can make a short issue out of the next three. Instead of copying the cell and pasting it to the others, go a different route. Your cursor on cell C2, guide your cursor to the formula line just below the menu bar. Select this entire formula line and on the keyboard strike Ctrl-C for copy. Hold it in RAM memory. Notice there are no ants marching around this time because we did not copy the cell. Now put the cursor in cell D2 and on the keyboard type Ctrl-V for paste. If you strike Enter, you will see exactly the calculation for January on average precipitation. We want minimum temperature for this column and the only difference is found in the reference columns used in the main entry array. No problem. Put your cursor back on the formula line for this cell and navigate to the end of the command where it presents $C $12 colon $C $1535. Change those C letters to D. The D column in the main array is where min temperature is found. Change them and strike enter. Completed to see the minimum average January temperature has been 22.11 degrees Fahrenheit. Set your significant digits again. Repeat this series for the average temperature. Use the same series of data held in your clipboard. Cell E2 and Control V for paste. You did it before, so change the $C $12 $C $1535 to put E in the place of C. Strike enter. Adjust the significant digits again and see 28.42 degrees Fahrenheit as the mean average January temperature. Yeah, great. Now do it again for column F and change that $C $12 colon $C $1535 to put F in the place of C. You know all the steps now, and you did it 3 times, and now you have experience. Well, select cells D2 through F2 to see our friendly plus sign in the lower right corner of this array. Double-click it, and the formulas are all replicated down these rows. That was good. Look at your data to see if it makes sense. Min is lower than average, which is lower than max. Well, sure. These are looking like the data I wanted to determine. While I am taking steps for success, this is a great time to save your file. Keep your safety engaged. Remember, you made this an XLSX file to convert it from the CSV you received it as. Only the binary file of XLSX can keep these formulas operational. Now, we make some charts to display these data. Select the tabular summary cell you made, C2 through F13. You can use the keyboard and shift with arrows or click and drag with your mouse. With these cells selected, take your mouse back to click on the Insert ribbon. See the Charts panel appear. There are a couple of ways you can do this, but I will demonstrate making them all as line charts. I choose the upper left image for this example. The program responds by dropping these data into line charts, all 4 of the arrays. It put the chart on the worksheet face. The next thing I do is to right-click on the chart image. See the command Set Applet appears. Partway down this list is Move Chart. Click on this and now select New Chart, and maybe give it a new name. This moves the chart to its own sheet where only the chart is displayed. Super! We can move into a new Excel reference area. We know the ribbons of Microsoft commands, but when you click on the chart, you will see a new set of super ribbons appear. They are not seen until you select a chart. Do not select specific data on the chart, just click on the chart edge area. Great. Now you see chart design and format as super ribbons. You need these now. We want to make the precipitation line go away and come back as a bar chart display with its values presented on a new vertical axis. Do this by clicking on the Change Chart Type icon. A new applet appears and you will go to the bottom of the left side list to see Combo. Click on Combo and yet another applet appears. On this applet, you see some attempts made by Excel, but ignore them all for right now. Look to the lowest series of dataset summaries. See Series 1, 2, 3, and 4 to the left. In the Chart Type pull-down menus, you see clustered columns and lines randomly assigned. Change these to pull the chart type selections for Series 2, 3, and 4 to become displayed as lines. Leave Series 1 as a clustered column, but click the box for Series 1 to be displayed on the secondary axis. Now, look at the thumbnail image to see this is looking sharp. It is time to click OK and make it go away. Wow, this is looking good. You know these data and now you know how they look. This is the chart you will use in your term report section on climate, but only with your description of what it means. You know it all, but it is not yet ready for presentation. You need to attribute it with the meaningful information. Our axes are naked. We need to dress them up. Right-click on the middle of this screen to select Data. It opens the main controller for all charts made in Excel. Here is where we tell the program about our data. Start on the right side panel for horizontal axes labels. Click on the Edit button. A sub-menu appears asking where the labels can be found. See the little upward arrow in the axes label range. Click it. It wants the address. So, using your mouse, open the Sheet 1 table we created for these data summaries. Remember that Jan, Feb, Mar column? Well, this is where they are used. Click and drag these cells to select them. They appeared in the Axis Labels applet. Click on the downward spacing icon. A new applet appears. Click OK. You see the month names appear for the horizontal axis labels. And great. Most of the time, those labels will appear right away. Sometimes I need to repeat this to make it work. We step again into the chart. Right-click to see the Select Data command. I want to inform it of the labels for the vertical axes as well. We look to the left side panel of options. Begin with Series 1. Click on it and select the Edit button above. It needs to know where that label is found. You know it as Sheet 1, so select it and click on C1. Click on the Capture button and then click OK. Right away, the label was updated on the main menu display. Do this again for each of the series in this array. Do a quick visual confirmation and see that they are looking right. If the months are not showing up here, select it again. It sometimes happens, and this is where you... When all looks good, click OK, and the applets go away. Now, I show you a tiny display augmentation. Double-click on the maximum temperature line. You see boxes selected all along this line. A new right side panel opened. Click on the paint bucket icon. It opened a new adjustment series for this line. You can set the color, width, and other features. I take you to the bottom of this list to see the smoothed line checkbox. Click it. Now the line showing 126 years of data shows a smoothed line. That is appropriate. Do the same for all the other lines on this chart. We are still missing a few labels. Select the chart with a click on the edge of it. You are not selecting specific data on the chart. Select the entire image. Super ribbons opened again. See these on the right menu area. Click on the Chart Design super ribbon to see on the far left side appears Add Chart Element icon. Click this to see Axis titles appear. Hover over this and another sub-applet pops out. At the bottom is More Axis Title Options. Click this and empty labels appear all around the chart. Super. Now you can see where the axes represent your data. On the right side of this chart, it shows Precipitation. So I click on the axis title and type what it should show. Precipitation, parenthetically IN. On the left vertical axis, I label it as temperature, parenthetically F. The horizontal axis is labeled as months. Big One wraps this one up. You need to label the chart of climate telling location and the period of years you show. This is mandatory. Okay, looking good. So, save this file again. Just do it. Some more insignificant housekeeping tasks involves selecting one of the bar charts with a double click. This opens the Format Data Series panel. Right side of the display. Take your mouse to the gap width, where it shows 150% by default. Shrink this percent to see what happens. Take it down to the more and more of the display. It's looking like a nice chart. When you get this looking like it is game ready for insertion into your MS Word term report on climate, you will port this graph to the document. Be cautious about how you do it. If you simply copy and paste it into MS Word, Then the MS Office array will make a complete link between the chart in Word with a hand-holding bond to the source in Excel. This means that if your Excel file is on your machine as you open in the Word file, all displays will be fine. But when you separate these two documents, like when you submit your term report through the Learning Management System or Canvas LMS, the chart will fail to open. It's looking for the source in Excel. You can select the chart on this screen and select Copy, then go into your MS Word file and paste Special. On the drop-down menu, you will choose the Paste Picture option. It will be a flat image that cannot be edited. The other option on this screen is to click on the chart in this area away from specific data. Go to the edge and right-click. You see a drop-down menu appear. Look near the bottom of this list and select Save As Picture. The program is ready to save this as a PNG file in a location where you want it to be. Do it and give it a meaningful name at a location you will find. You will insert this image into your report. Cite your sources and label it appropriately. I remind you again, save the file. We spin around again to the WSU Virtual Ecology YouTube monthly 360-degree camera images taken on the north-facing aspect of Kamiak Butte. I want you to find matches to the data by using the address to WSU Virtual Ecology YouTube channel shown here. Open this view to see how the combination of temperature and precipitation is revealed as growth in the understory vegetation. You see it change through the growing period of May through October, and then in November, all is brown. By January, snow is on the ground and persists in 2021 through to early March. Still, plants do not grow until May flushes in. Yes, understory plants are greening up. Verdant growth is seen as a response to the combined temperature and precipitation. These are all taken at the same point each month, all ready for about 24 consecutive months. I'm spinning this in circles to let you see what the data tells. As you prepare your climate term report section, I want you to go into this 360-degree camera show to select at least 2 months of significant climatological evidence. Make copies of your selected images. Make sure you can cite them and put them in your report. Use the PRISM data to link images with data report and figures. This is a tool to show your best approach to describe your weather data translated into climatological trends. This is climate. You can make a powerful and persuasive discourse based on this. Remember that you are doing this for our sample ecosystem, but you can repeat this on any site where you are tasked to work. Set the example of how to make it part of your analytical assessment prose. When you write this climate report, make it a standalone document about the climate of Kamiak Butte. Describe the climate using all available measures. PRISM data are a core part of this, but the 360-degree camera images and the wildlife camera trap shots serve this too. These discussions will integrate with all other aspects of the master report you prepare. Make this document a solid report about climate.